Hello, invisible students. I hope you're doing fantastic. We are going to start with the half angle formula today. And there are half angle formulas for sine and cosine and tan. We're just going to work with cosine. And the reason why is because we're working remotely and we're doing the best we can. So I don't want to overcomplicate things. So let's just work with the half angle formula for cosine. So if we've got cosine of 60 over 2, what's my theta? Well, you can see with the formula that the theta is that value on top. Let's go ahead and let's actually figure out, does this formula work? And to do that, I'm going to simplify my cosine of 60 over 2, and obviously 60 over 2 is 30. Okay. Well, what is cosine of 30? That's the square root of 3 over 2. And if you're trying to figure out, Ms. Sorensen, how'd you get that? Just go over to your unit circle right here and find your 30 degrees, which is right here, and you're picking your first coordinate. Remember, computer science. First it's cosine, then it's sine. All right, so let's go ahead and apply this formula. And first of all, if I'm finding cosine of 30, what quadrant am I going to be in? I'm going to be in the first quadrant where everything is positive. So I'm going to pick the positive for this. So this is going to be the positive square root of 1 plus cosine of theta. Remember, your theta is the value in the numerator here. So in this case, this is going to be 1 plus cosine of 60 divided by 2. Okay, well, what is cosine of 60? We have to go to our 60 degrees now, and we have to find the first coordinate, which is going to be 1/2. So we're left with 1 plus 1/2 all over 2. Now, how do we add 1 plus 1/2? Well, 1 plus 1/2 is really 2 over 2, which is 1, plus 1 over 2. And that's going to give me 3 over 2. All right, so that changes my numerator to be 3 over 2 divided by 2. Well, what is 3 over 2 divided by 2? Well, let's do that math on the side here just to keep things neat. 3 over 2 divided by 2 is the same thing as multiplying by the reciprocal. Well, what's the reciprocal of 2? That reciprocal is 1/2. Okay, so 3 over 2 times 1 over half, we multiply across the numerators, and we get 3 times 1 is 3. Then 2 times 2 is 4. So this is going to give me equal to the square root of 3 over 4. Well, square root of 3 divided by the square root of 4, we can just break up those square roots, so we're left with the square root of 3 over the square root of 4. And what is the square root of 4? Well, that's simply 2. So I can go ahead and rewrite this as the square root of 3 on top, and then of course, like I was saying here, square root of 4 becomes 2. And I'm just going to rewrite this going straight down, no problem doing that. And is it true that square root of 3 over 2 is equal to square root of 3 over 2? Yes, it is. All right, let's try another one. I think this is our last one for verifying that the formula works. What is the theta in this situation? Well, of course, it's 2 pi over 3. Okay, and cosine of 2 pi over 3 divided by 2, let's again go over to do our side work over here. Dividing by 2 is the same thing as multiplying by 1/2. So this is really giving us 2 pi over 6, and reducing 2 pi over 6, we get pi over 3. So this is actually asking us to find the cosine of 2 pi over 6, which we just said is reduced to cosine of pi over 3. Okay, well, what is the cosine of pi over 3? Let's go ahead and look over here. Pi over 3, first symbol here, so that's going to be 1/2 right there. So all I've done is just kind of reduce this here and realize that it's actually just pi over 3, which is 1/2. Now, if we're having the cosine of pi over 3, again, we are in the first quadrant, so this is going to be a positive when we do this problem. And I'm going to give you kind of a better way of determining if it's positive or negative once we actually do one of these problems. So this is going to be the positive of 1 plus cosine of, remember, theta is just going to be the value that's in the numerator here. In this case, it's going to be 2 pi over 3, all divided by 2. Okay. So cosine of 2 pi over 3, I've got to find that, and 2 pi over 3 is right here, and that cosine is a negative. Okay, so we've got the square root of 1 plus a negative 1/2 all over 2. Okay, let's go ahead and let's go off to the side here and do 1 plus negative half. Well, that's really 1 minus a half. So that's 2 over 2 minus 1 over 2, which is 1/2. And you could have thought about that reasonably, right? 1 minus a half is clearly a half. So this becomes the square root of 1/2 divided by 2. Well, what is 1/2 divided by 2? Well, that's the same thing as doing 1/2 times the reciprocal of our denominator, and our reciprocal of our denominator is a half. So that's going to give us 1/4. So this is just going to simplify to the square root of 1/4. Well, what is the square root of 1/4? Again, we can always break that up into being the square root of 1 over the square root of 4. And what's the square root of 1? It's 1. What's the square root of 4? It's 2. So this is going to give me 1/2, and this is going to give me, just drop down right here, another 1/2. And so that is verified. Definitely a little bit harder math here dealing with the fractions, but it's the same process as the double angle formula. All right, here we go. This is just like your double angle formula, except this time I'm asking you for cosine of theta over 2, and before I was asking you for sine of 2 theta. And it's pretty darn obvious we have to use the half angle formula because it says theta divided by 2. All right, folks, first thing that we're going to do is find out where we're at in our quadrants here. So we're between pi over 2 and pi. Well, pi over 2 is right here, and pi is here. So drawing that triangle, we have our theta right here, and it's going to be opposite over adjacent, so that's going to be, because of tangent right here, we've got opposite over adjacent. So my opposite's going to be 3, and my adjacent's going to be 4. Which one should have the negative here, the 3 or the 4? Well, from our problem, it's almost implying the 3 is negative, but in reality, we're actually going left 4 and up 3, so actually the 4 should be the one with the negative. And that's not a mistake up here. We can put our negative with the numerator, we can put the negative with the denominator, we could put it on the outside. Doesn't matter. All right, what have we got here? We've got a 3, 4, 5 triangle. So I'm just going to go ahead and write that 5 right there. And I want to make an estimate about where theta over 2 is going to be. Well, first of all, what have we got here? We've got this right here and that. That's our theta. And I know I kind of said that this was theta, but we just use theta to say angle. I wish I could go back. I don't know how to do it. I'm sure there's a way. Okay. But what is that red angle? That's actually our theta for this. Theta here is just talking about our reference angle. So theta divided by 2, well, what is that red angle? Well, it's more than 90. Let's just go ahead and estimate it to be 100. So what do I care about? I care about theta over 2. So if my red angle there is theta equals 100, I think it's probably more than that, but no big deal. We're going to divide that by 2, and we're going to get theta over 2 is equal to 50 degrees. Now you might be saying, Ms. Sorensen, isn't that a check step? Well, it was for the double angle formula for sine, but here we actually have to choose if it's positive or negative. And so we have to do that step as part of the actual problem to figure out if our answer is going to be positive or negative. We didn't have to do that in sine because it kind of did it for us in the formula. It figured out if it was positive or negative. All right, if we're going to find the cosine of 50 degrees, is that going to be positive or negative? Well, it's going to be in the first quadrant, our theta over 2. And We also know that all students take calculus. So if our theta over 2 is in our first quadrant, and all of them are positive, we should be choosing the positive here because we're in quadrant 1 and cosine is positive in quadrant 1. All right, so now we're ready to just start this problem. We now know that cosine of theta over 2 is going to be equal to the positive of 1 plus cosine theta over 2. Now we need to find what cosine theta is, and this should really be part of our first step over here as well, but you can do it now if you want. Our cosine theta is going to be adjacent over hypotenuse, and our adjacent in this case is the -4, our hypotenuse is 5, and we can also label this side. So our cosine theta is adjacent over hypotenuse, which is -4 over 5. So now I'm going to rewrite this as cosine of theta over 2 is equal to the square root of 1 plus a -4 over 5 divided by 2. All right, now let's go ahead and let's do this math. I'm going to pull this out, and 1 is equal to 5 over 5, and we're adding a -4 over 5. Of course, that's going to give us 1/5. Okay, so 5 plus a -4 is a 1, and of course we keep our common denominator. And don't forget about your divide by 2. So now, if I want to do 1/5 divided by 2, you should know that 1/5 divided by 2 is the same thing as 1/5 times 1/2, which is equal to 1/10. So this is equal to cosine theta over 2 is equal to square root of 1 over 10. Now, is that reducible? It sure is, right? We know that we can write this as square root of 1 over the square root of 10, and that's going to be equal to 1 over root 10. Well, 1 over root 10 has a radical in the denominator, as does this as well, because it's square rooting the whole thing. So we've got to rationalize this, so that's going to be 1 over root 10. Rationalizing is going to be root 10 over root 10. That's going to give me square root of 10 over 10. How do I get 10? Well, square root of 10 times square root of 10 is 100. Or you can think about it as the square roots disappear. And of course, square root of 100 is 10. So our answer here is equal to, hello, equal to the square root of 10 divided by 10. And I never say, hey, rationalize, but you should say to yourself, okay, I know Miss Sorensen wants everything rationalized. All right, so that's our answer right there. All right, find cosine of theta over 2 for this particular problem. All right, I believe this is our last one. Nope, we've got one more after this. So example 4 here, we've got sine theta is -12 over 13. Let's go ahead and draw that, and that is going to be located in between pi and 3 pi over 2, so I know that's located right here. I'm going to draw that triangle, and that's going to give me my theta here, so that would be opposite over hypotenuse, would be a 12 here and a 13 here. And you should have this memorized. What type of triangle is this? This is a Pythagorean triple, so this is going to be a 5, 12, and 13. Now, left, right, up, down, let's make sure this 5 is going left, so this is going to be a -5. This 12 is going down, so that's a -12, and our hypotenuse is always positive. And I think we learned last time that we really should also grab a cosine theta and determine what cosine theta is. So here we've got, oh boy, cosine theta is equal to adjacent over hypotenuse, and as a reminder, we've got our opposite, our hypotenuse, and our adjacent. So adjacent over hypotenuse in this case is going to be -5 over 13. All right, what else we need to figure out? We need to figure out what quadrant we're in for theta over 2. Well, first, to do that, we have to estimate what theta is, and theta is going to be this angle right here. being this angle right here. So theta is going to be, I don't know, 180 plus a little bit. I guess I'm going to guess, I don't know, 200 degrees to make my life easier. So theta is going to be 200 degrees, which actually means that my theta over 2, or cutting that in half, is going to be 100 degrees. Well, where's 100 degrees located? It's located in the second quadrant because it's bigger than 90. So we know that we're going to be in the second quadrant for cosine. Is that going to be positive or negative? Well, all students take calculus. And if we're in the second quadrant for cosine, and only sine is positive in the second quadrant, we know that our answer is going to be negative here. So what do I have to choose? I have to choose the negative when I'm doing this formula. So cosine of theta over 2 is going to be equal to the negative of the square root of 1 plus cosine theta over 2. And let's just go ahead and work this down a little bit. We know we're going to have that negative square root. And this is going to be 1 plus, and I'm going to go back to my cosine theta right here. And remember, I'm plugging in for cosine theta here. So that's going to be negative 5 over 13 all over 2. Okay, let's go ahead and combine that numerator. So I'm going to say 13 over 13. Why did I say that? Well, I've got a 1 right here, right? And then I've got to add a negative 5 over 13. Well, that's going to give me 13 minus 5, which is 8 over 13. So this is going to be equal to the square root of 8 over 13 divided by 2. And don't forget my negative. All right, what is 8 over 13 divided by 2? Well, that's the same thing as multiplying by a half. So that's 8 over 13 times a half. Multiply across and you get 8 over 26. Okay, what does 8 over 26 reduce to? It looks like I can divide both of those things by 2. And 8 over 26, dividing both by 2, I get 4 over 13. All right, so this gives me equal to negative square root of 4 over 13. And you guessed right, we can reduce that as well. What is that going to give us? That's going to give us the square root of 4 over the square root of 13. Well, what is the square root of 4? It's 2 over root 13. And now I need to take that time to rationalize my denominator. So this is going to be 2 over root 13 times root 13 over root 13. And this just simply becomes 2 root 13 over 13, because remember our root 13 times root 13 cancels out. So our answer is going to be a negative 2 root 13 over 13. There we go. All right, I got one more problem for you here. We've got cotangent theta equals negative 8 over 6. It gives us our restrictions on our domain, and we're asked to find cosine theta over 2. So let's go ahead and recognize where this is. This is going to be on your fourth quadrant right here. We know that because this is 3 pi over 2, and this is 2 pi. We're told the cotangent of theta is adjacent over opposite. Remember, that's the reciprocal of tangent. So our adjacent is going to be right here. Our opposite is going to be right here. And we'll deal with that hypotenuse in a hot second. Okay, if we are going right for 8, we are positive, and if we're going down for 6, we are negative. Now our hypotenuse is going to be what? Well, it's awesome if you do Pythagorean theorem, but it's a lot faster if you recognize this as a 3, 4, 5 triangle that is a similar triangle. This is actually a 3, 4, 5 triangle that's been doubled in size. It's actually doubling 4, you get 8. Doubling 3, you get 6. And if this is doubling 5, you get 10. So this is kind of nice. This is a Pythagorean triple. Hopefully you recognize that. If you don't on a test, you would just do Pythagorean theorem to find your hypotenuse. It'd just be a little bit extra work. So here we've got 10. All right, sweet. Remember, I'd like you to find cosine theta at this point, and we can deal with where theta over 2 is in our quadrant as well. But cosine of theta is going to be adjacent over hypotenuse. In this case, we've got adjacent in our hypotenuse, and if we care to write our opposite, it's right there as well. So we've got cosine of theta is adjacent over hypotenuse is 8 over 10. And I would say don't reduce that. There's no need for that. Okay, let's go ahead and estimate where theta over 2 is, just so that we can identify if it's positive or negative in this case. Well, so far for our angle theta, we are at this. So I'm just going to estimate that, I don't know, theta is roughly 300 degrees. Why do I say that? Well, that's a 90, 180, 270, and a little bit more. So that means our theta over 2 is going to be equal to 150 degrees. Well, that's less than 180, right? So that's located about right here for theta over 2. And if our cosine is in the second quadrant, it's negative. And if you're not sure why, that's because all students take calculus. Here, the S indicates that only sine is positive, so cosine will be negative. So we know that our answer here is going to be cosine of theta over 2. It's going to be equal to negative square root of 1 plus cosine theta over 2. All right, let's go ahead and start reducing that. That's going to give us equals a negative 1 plus, what's our cosine theta? It's 8 over 10 divided by 2. All right, let's combine these. So 1 is equal to 10 over 10 and 8 over 10. Combining those fractions, we get 18 over 10 because we keep our denominator the same. And reducing that, we can divide both by 2, and we get 9 over 5. Okay, so all I've done right here is do the numerator. So this is going to be equal to negative 9 over 5 divided by 2. What is 9 over 5 divided by 2? Well, dividing by 2 is the same thing as multiplying by its reciprocal. So that's 9 over 5 times 1/2. Well, that just is simply going to give us 9 over 10. So what we've got here is equal to negative the square root of 9 over 10. Okay, can we simplify the square root of 9 over 10? Certainly we can. That gives us square root of 9 over square root of 10, which gives us 3 over root 10. Now we have to go ahead and rationalize that. That's 3 over root 10. We need to multiply by root 10 over root 10. And that's going to give us 3 root 10, and then square root of 10 times the square root of 10 is the square root of 100, or we can think of those square roots of canceling. Square root of 100 is 10, or square roots cancel, we're just left with 10. So our final answer here, of course, is that negative 3 root 10 divided by 10. That's it, folks. Thanks for watching. Hope you have a fantastic one.